You may have heard me say this on other podcasts, but this is something on which my opinion has changed. You asked me 25 years ago when I first started, exactly like Chris. I'm like, no, animal proteins are higher quality. They've got more essential amino acids. They're more digestible. And I'm beginning to think that that's less and less. In fact, for the most part, it's a non-issue.
Welcome to the Proof Podcast, a space for science-based conversation exploring the health and longevity benefits that come with mastering nutrition, physical exercise, mindfulness, recovery, sleep, and alignment. Facts, nuance, and trustworthy recommendations, minus the hyperbole. Gentlemen, welcome to the show. I'm glad that we finally have this opportunity to talk all things protein.
All things protein.
Great to be here.
Thanks, Simon.
So we've been going back and forth on emails for a couple of months now, sort of trading thoughts and ideas about all things protein and what's the adequate amount and what's the optimal amount. And there are lots of different opinions about this in the literature and online. So looking forward to trying to walk through some of this and clear some confusion, find out where you guys agree and where maybe you disagree and why. And for background, the kind of inspiration for this episode actually started from a sort of Twitter thread between the two of you, a bit of a back and forth scientific discussion that I really enjoyed and thought, well, wouldn't it be great to have an actual conversation together? Something that Twitter doesn't always allow for is expanding and getting into a little bit more of the nuance. So I'm looking forward to kind of digging into that with both of you today. And just to preface this, because when protein comes up, I guess there's people sort of coming into this from different angles. I wanted to really focus on the average adult today in Western populations. So not so much the athletes, but whether the sort of current recommended dietary allowance is the optimal amount to support an adult as they're aging. And we can, I guess, define what optimal is. When I think about that and supporting healthy aging, I think about, well, firstly, musculoskeletal health, so things like bone mineral density, skeletal muscle preservation, strength, etc., which I guess tie into that idea of frailty. And then at some point, perhaps we can widen the lens and look at protein and perhaps how that may influence our risk of developing cardiovascular disease or cancer, the top two causes of death. So I want this to be really free-flowing, so I'll throw some questions out, but I'd like the two of you to kind of jump in when there's gaps and ask each other questions. Stu, perhaps I can throw the first question at you here. I know that you're of the view that the RDA, or at least I believe this is your view, that the RDA for protein is actually not what would be described as optimal for the average adult. Can you kind of kick things off by sort of telling us about your thinking process here and why you've landed in this position?
Yeah, I mean, I think that there's several things. First, the methodology that establishes the recommended dietary allowance, right? And I've said in the past, and some people get a little bit twisted about this, is that if we called it the minimum dietary intake, I could actually sort of walk away from this and not really talk about it anymore. But I don't think it should be recommended, and I think you should be allowed to eat more. But let me just say that, nitrogen balance, like a lot of balance studies, is a flawed methodology. The flaws are well known, and yet it's still the methodology that people sort of say, well, we have the most data on this, and it's unlikely that it's going to change at this point. I don't think anybody's in a real hurry to conduct a series of nitrogen balance studies. I've done a few myself. They're not a lot of fun. But there's an increasingly positive nitrogen balance with increasing intakes like ad infinitum, which would suggest that people are accruing protein. We know that that's not the case. And the linear model, which is the current model that, the Rand and Pellet paper, which is the Citation Classic, on which requirements are based, actually takes out some data points which change the answers to the question. I don't think a linear model is the right way to look at it anyway. And when you add on top of that other approaches, and particularly the indicator amino acid oxidation method, and several other findings from our lab and others show that synthetic rates of proteins, blood-borne and muscle-borne, continue to increase even when you're taking intakes above the RDA, which implies right away that the RDA is insufficient for optimizing anabolism. So, by definition, that means that the RDA is insufficient.
Christopher, is there anything that you'd want to kind of ask there or comment on with regards to the RDA and I guess the studies that are being used to inform it having flaws?
Yeah, so the whole question is insanely challenging because what is optimal? Is it all optimal for building muscle? Is it optimal for maintaining muscle? Is it optimal for preventing heart disease and cancer? And if you go back to when this was done, these nitrogen balance studies, I don't want to make this too personal, but I got my PhD at Berkeley, Stu, where Doris Calloway and Shelley Morgan in the 70s had conscientious war objectors from Vietnam. They stuck them in the 5th floor, the penthouse of Morgan Hall. They locked them up in zoot suits. They collected all their shit and all their pee and all their nasal blowings, right? And anything that sloughed off their body. And they did these insanely elaborate studies of nitrogen in and nitrogen out, which I wonder if was cutting edge at the time. They really are disgusting sounding studies, right? As you alluded to. Nobody wants to do these again.
Yeah.
They lowered nitrogen intake to 0. And then they saw how much nitrogen was coming out. And then they said, is that how much you have to replace? And sort of a really pivotal finding back then was that as they started refeeding them nitrogen, they found out the body was being really efficient when they were getting 0 nitrogen. So the amount they were losing, the amount of protein they were losing wasn't the amount that you needed to replace. As you started feeding them more protein, they weren't as efficient. And so they got up to this point where they said, now we're in nitrogen balance. Now the amount of protein or nitrogen going in is the same as going out. And Simon, for listeners, I mean, it would be important to clarify the whole reason they did that is because protein itself is challenging to monitor, but an interesting aspect is almost all the nitrogen that comes into your body and leaves is protein related. Nitrogen is in all kinds of other things in your body, but quantitatively, protein is the major source of where the nitrogen is. So it's actually kind of clever that they had this proxy and they pooled a bunch of studies like this. And Stu, you can correct me if I'm wrong. I'm not sure if I know all the details, but the time they pooled the data across different groups and put them in the IOM's report, the DRIs, I think they're in the 2005 tome of protein and carbs and fats and things like that. They said, okay, here's the estimated average requirement. That was really fascinating, Simon. I actually get a bunch of aha moments when I'm trying to explain how those RDAs came about. They had a normal distribution of individual requirement that they figured out whether the systems are flawed or not, the nitrogen balance method. They had a normal distribution. Most people needed average. There were people at both ends. Then when they make the recommended daily allowance, they don't promote the estimated average requirement. That would be a loser from the beginning. So if everybody got that estimated average requirement, by definition, half the people would be deficient because they're on the top of the normal distribution curve. And so they take 2 standard deviations above that, which technically exceeds the requirement, okay, flawed or not, Stu, exceeds the requirement of 97.5% of the population. And as soon as I say that, people say, oh my God, that's how they calculated it? I didn't realize that was the approach. That's really different than what I thought. I assumed they were calculating the average. So as I teach this concept about nitrogen balance, normal distribution, estimated average requirement, recommended daily allowance, I know these might be too geeky for some of you, but I'm sure some people are going to like that aspect. So let's think, that's the method they used. It's back in the 1970s, as far as I can recall. It's really icky. Nobody's ever going to do it again. Stu, I don't know if you get this, but when I'm talking about this in the class, a couple of students say, well, I'm up for estimating my individual protein requirement. And then I describe the method that they went through and I'm out. Nope, not me. I'm not doing that. And so what we have to have is proxy measures And that gets back to how I started this whole conversation. Is it lean muscle maintenance? Is it gain? Is it sarcopenia? Is it prevention of chronic disease? So it's really a challenging question to frame how you're going to say what the requirement for protein is.
Stuart, I've got a question for you that kind of, I guess, follows on from that. When you're thinking about the RDA and your position is that you don't think it's optimal, what's your definition of optimal? So what are you thinking about sarcopenia, or is it bone mineral density, or is it function? What's the sort of meaningful, I guess, outcome of interest for you? And then in addition to that, with everything that Christopher just went through, is the buffer that's been added to the estimated average requirement through this 2 standard deviation increase to get to the RDA, is that sufficient to overcome the potential flaws in the nitrogen balance studies?
Well, I think what you have to ask yourself, if somebody's in nitrogen balance, what's the associated physiology or relevant marker that would speak to the optimization that you care about? Because the answer is there is none. Like, there is no physiological correlate that's associated with being in nitrogen balance. So not even nitrogen balance can give you an answer as to whether it's supportive of optimal rates of protein synthesis. We know for a fact that when you near requirements, you get much more efficient. And it makes sense. I mean, that's how humans have survived as long as we have. So the premise of the method and the method itself can't give you an answer to the question. So there's 2 questions being asked here. The first is, what's the minimum amount of dietary protein that I need and I can survive on? And chances are that the RDA maybe is close, but we don't know. We don't have a good method to estimate it. So, like, I agree with Chris. The description is spot on. Tons of detail in those studies, tons of all kinds of data. They're estimated on a group of individuals. We make the assumption that they're representative of everybody. I don't know whether everybody believes that there are 280 some odd people, which are the number of nitrogen balance points that went into the IOM report, represents everybody in North American or Australian society. But it's simply, the method doesn't answer the question. So it's sort of a moot point to say, do you believe that adding 2 to something that we don't know is makes it a good requirement? My answer is, you have no idea. I'll say this, is that estimating an optimal requirement is exceptionally difficult. It could be body composition related, and that speaks to a lot of the work that we've done. It could be related to other health outcomes. And I think one of the things that you have to remember, like in North America anyway, is that the acceptable macronutrient distribution ranges, which the Dietary Guidelines Committee have agreed are associated with, their words, good health, put protein at anywhere from 10 to 35% of total energy intake.
I want to take issue with that. Keep going, but I want to come back to that.
But hold on. So that concept is inconsistent with saying the RDA, because it really does flatten out the whole argument. So small point, the distribution wasn't normal. It tails off to the right, but when log corrected, it becomes normal. But so. Yeah, sorry, Chris, you had a rejoinder you wanted to make.
I find the AMDR, the acceptable macronutrient distribution rate, a little frustrating, because as I understand it, and could be wrong, so happy to hear back from you, Stu, they're kind of realistically trying to think about carbs and fat. And they said, okay, so carbs can be
absolutely,
carbs can be this and fat can be this. And if you're at the lower end of carb and if you're at the lower end of fat, it has to add up to 100%. What's left? And it's 35%. And I don't think that 35% was anywhere near intentional, other than math. And it'd be fun to get back to you on this.
I don't disagree, okay. but let's be clear. One of the things that the AMDR assumes is that there's a requirement for carbohydrate. And we know that that's not true. Carbohydrate is fuel, so is fat. And I mean, there's a tiny requirement for essential fatty acids. So the only functional macronutrient is protein. So I don't disagree that 35 is, it's a ridiculously high amount. But it's still in there as the number, and it may be just math that it's left over, but it does suggest at least that, if you're going to say it's associated with good health, then is it or is it not? And I don't disagree that it's the math that's left over, but it really does hammer home the point that carbohydrate needs, quote unquote, are effectively zero. I mean, ketogenic dieters everywhere have shown us that's the case. So there's a flaw in the estimation of the acceptable macronutrient distribution ranges, maybe.
There is. And so a funny point that I bring up for my class all the time is I show a bunch of distributions in class and I say, okay, here's all the ones that would fit that AMDR, and you probably never heard of these. Okay, now here are all the ones you've heard of. Mediterranean, that's outside, higher in fat. Here's keto, that's outside, lower in carb. Here's Ornish, that's outside, higher in carb. So all the ones that are popular that have been heard of are outside of the AMDR. So I'm really not sure what purpose the AMDR serves.
Well, it's like the argument about the RDA. Either we have a target or we don't. Yep. And so my position is we have no idea how much protein people require. So because the method that we're using currently is flawed, but several other methods estimate that the need, if that's the right way to say it, or the intake at which protein synthesis of any kind of protein is maximized is higher than the RDA. Like, by definition, you can't have that and say that the requirement is correct. But again, it's sort of like as if somebody came down from the mount and chiseled in the RDA as the requirement, and thou shalt never change it. So
Got it.
I realize I'm fighting a losing battle when I'm having this argument, because all anybody defaults to is, well, the WHO and I'm like, they're learned people, but we haven't had an update of that in over 12 years now, and there's been evidence since.
Let's bring this back to the average person who's listening right now, and so they're listening to everything that both of you are talking about, and
sure.
and I think this is what a lot of people are thinking. They're thinking, okay, should I target the RDA of 0.8 grams per kilogram, or am I going to get significant benefit, i.e. achieving this optimal sort of outcome, if I target, and I see different numbers thrown around, but I see 1.1 to sort of 1.3 grams per kilo thrown around, particularly in the discussion around maintenance of skeletal muscle, preservation of muscle as one ages.
Yep.
So my question to you is, it sounds like the sort of outcomes of interest for you are around skeletal muscle, at least mostly, and I'm interested in a couple of things here. What is the evidence that makes you, when looking at that area, think that the RDA is not optimal? And if we look at and you can kind of expand on what you think is optimal in terms of protein intake. And the second part of that I want to cover is, where is the average American adult at today in terms of their protein intake? And is it above or at the level or below the level of what you think is optimal?
You're right. I can't deny that, I live in a muscle-centric world, and so I view that as an important outcome. But it's not the only outcome that I care about. Body composition would be important. But to the points Chris made around, cardiovascular health, if we're talking about cancer, everything like that, who wants to have a lot of muscle and die at age 60? That's not a sensible approach. So, without going into too much detail, let's just say that in the original analysis of nitrogen balance, there were 13, or maybe it was 14 data points that came from older people, if that's, whatever that is, let's say in their 70s. And they were higher than the average, but in the, obviously eyes of the people that were setting the requirements, it wasn't sufficiently different. Now, other nitrogen balance studies have been done. Some find that it's adequate, others don't. Other methodologies put the requirement for an older person, and I don't know when older begins, but 50, 55, 60, I don't know, at close to 1.2 as a requirement. So the question then is, if that's the basal requirement, what's optimal? And that's a tough question to answer. From what we know from muscle gain studies, if you're a weightlifter, it's probably up to 1.6. There are some people who insist that it's higher than that. I don't think it is. But, we could, I fight with people on Twitter all the time over that one.
What's the average intake today in America?
Oh, yeah. No. So from that perspective, and, Chris has made this point abundantly clear, and he's entirely correct. People are getting 1.2, 1.3, 1.4, but not older people. And that's one of the points that I'm making, particularly as you get older, the choice is actually eat a little bit less. And the choices that people make in terms of foods are away from protein containing, and particularly some nutrient dense protein containing foods. And I don't think that that's, a deniable fact. But Chris has pointed this out. And I'll say this unequivocally. Athletes eat a lot of protein. And if you could find a paper that I've written where I said athletes weren't eating a lot of protein, then go right ahead, because I've never said that they weren't. But importantly, when I started doing this 30 years ago, all I ever heard was, the RDA is sufficient. Nobody needs any more, because they didn't study athletes, they didn't study enough older people, and lots of other groups. So it may well be true that the average person, whoever that is this somebody who's not obese? Is this somebody without type 2 diabetes? Is this somebody without, name your pathology, that probably about 2/3 to maybe 75% of Americans or, North Americans are walking around with? And it's a tougher question to answer.
Can I jump in on this? So that was great, Stu.
Yeah.
And Simon, I wanna give a shout out to Stu, because at one point we were having a mini little debate discussion. I don't really think it was an argument on Twitter. And I said, look, there's too few characters here. Can I just write you an email? Because I think Huberman was saying, this sounds like a great debate. Let's put this in a podcast. And I thought, I bet I agree with him on almost everything. So I wrote him a little message on the side and said, here's some of my positions. And he wrote back and said, yeah, it might be kind of boring. I guess we agree on more than we think. And I think what's important here, from my perspective, is that we have two really different disciplines. So if you guys will give me a couple minutes, let me share my perspective, my methodology, which is really different than Stu's, which is so mechanistic. And so my background comes from doing weight loss studies with average people, right, where I'm manipulating carbohydrate and fat. My perspective comes from working with the Menus of Change. It's this group of chefs and scientists that are trying to get people to eat optimally. And one of the issues of the Menus of Change is they're focusing on the protein flip, which is eating less protein and putting plants more at the middle of the plate. And at one point, they asked me to give a little Protein 101 seminar, and I did. And they said, no, really? And I said, yeah, these are some of the basic facts. And so let me share these with the audience, because I find these fascinating. And Stu, none of these are mechanistic. They're just super practical. And so as I look across the realm of nutrition studies, where we're trying to do diet assessment and collect what people are eating so we can see if they really are eating the macronutrients we wanted for a weight loss study or for some other kind of study, it is stunning how similarly people are eating, let's say 16 to 18% protein. It is staggering. And my favorite example of this is actually a weight loss study. It's called the Pounds Loss Study. It was this massive collaboration between the Pennington Research Center and Harvard. They each recruited 400 people. They had 800 people in a study for 2 years. And the design was pretty elegant. They were going to test protein, carbs, and fats at the same time, low and high. And so they had 2 fat levels, 20 and 40%. They had 2 protein levels, 15 and 25%. So focus on that for now. Low of 15, high of 25. And then they had 4 carb levels so that they could have 4 diets to do this. And they took extensive dietary assessment. And at the end of the 2 years, the protein question could not be answered. The two groups that were shooting for 15% protein were eating 20. The two groups that were shooting for 25% ate 21. They were virtually identical. And an important note in this weight loss study was that even though 20 or 21% is higher than the 16 to 18% I just said, they were eating fewer calories and they were losing weight. And so actually the number of grams of protein at 20 to 21% was really similar to what it was at baseline. And Stu, I was stunned that these folks were expected to change their protein and they couldn't do it. And I looked at some of our studies. I've done low carb, low fat studies, and they get some massive changes in ratios of fat to carbs. You look at the protein, it is hardly different. It might be different early on, 3 to 6 months, but at 12 months, even when fat and carb is very different, protein is virtually identical. It's like there's some inner metric that just says, okay, I'm gonna eat as much protein as I need, eat regardless of how much fat and carb that I'm eating. And so this has been really fascinating to me to see how somehow people are able to do that. So I went back to this IOM report, and you can see that part of that I hadn't appreciated before was a bunch of doubly labeled water studies that say how many calories we burn. And in our reports, I know the whole nutrition committee world is sort of famous for publishing studies where it appears the participants are underreporting their intake, so less than full accuracy. And so quite often we're getting reports of 1,800 to 2,000 calories. If you look at the doubly labeled water studies, it appears the average woman requires 2,300 calories to maintain weight, and the average guy is pretty close to 3,000. They're not reporting that. So what they are reporting is a really consistent 16 to 18% protein. But if you take 16 to 18% protein and you apply it to 2,300 calories a day for women and 3,000 calories a day for men, you are already at 1.5 to 1.6 grams kilogram body weight. So Simon, your initial question was, what's the average American eating? What's the average Australian, Canadian eating, North American? I think they're already eating 1.6. So Stu, when your paper came out and said, and I've seen several of these, 1.6, you might need 1.6, but above that, it's not helpful. My first reaction is, that's what the average person is eating. So we don't need supplements. We don't need protein bars. And the athletes who are doing this are eating more calories than the average American. So they're already getting more than 1.5 and 1.6. That was my rant.
Just quickly, before Stu jumps in, I'm sure he has a few things to say. I just wanted to put this out there. Have either of you come across the work of David Raubenheimer and Stephen J. Simpson out of Sydney? They wrote a book called Eat Like the Animals.
Yep.
No.
So I think, Christopher, based on what you just explained then, you'd be fascinated by their work. They have looked at a lot of different animal models from starting, I believe, in locusts and also in primates, and looking at what they describe as the protein appetite, and this very strong appetite for insects and animals to essentially eat until they meet this protein appetite. And they've displayed a number of different models where an animal will even overconsume calories or fat in order to achieve a certain amount of protein balance that they're very good at. And one of their main hypotheses is that today, if you put an animal and take it out of its natural sort of environment and put it into an environment like today with a lot of ultra processed foods and hyperpalatable foods where protein has been diluted, that people will overconsume calories to meet a sort of basic or adequate amount of protein balance. But I just thought I'd throw that out there. It might be interesting for you to look at their work.
Yeah, I think that, that leverage idea that you just mentioned, Simon, it does speak to, a point that Chris brings up. And I don't disagree that, most people tend to settle in at around 16 to 18%. So if there is this leverageable protein idea that, Simpson and Raubenheimer champion, And the data from animals seems a little bit more compelling than the data from humans. It's true that if you feed people 5-10% of energy from protein, they tend to eat more to seek the protein. Makes sense. It's the only required macronutrient. You don't need carbs. You need a tiny little bit of fat. And so your body would have some sort of protein stat to seek that. But surely it's capped out and its maximum capacity is to satisfy requirements. So again, we come back to the question, is it a requirement or an optimization? And they're different.
Yeah.
It's simply a different paradigm. And the optimization question is much more difficult to answer. So, like Chris said, it's odd, right? You exchange an email and we think we're sitting on, different sides of the fence. I think we see things largely the same, except maybe with my exception that I think a lot less people are hitting that 1.5, 1.6, particularly as they get older. And we're looking at a global aging population where it's a time when actually it's the reverse of growing. Kids actually, they're in a remarkable situation because linear growth is driven by all kinds of things that actually are sort of nutrient inflexible, or I'm going to say nutrient flexible. And protein probably, as long as you get some of it, you tend to grow and you're not deficient. As an older person, you're preventing the downslide, and that's a little tougher to pin exactly where that is. But even if you do that, then their requirement is probably close to 1.2. I don't disagree. And I've never said like there's a rampant population protein deficiency. But, I get tired of hearing the RDA is enough. This is an old argument. We just don't need to talk about that. And that's the argument that is persistently, and in the last 30 years that I've been doing this, what I've heard. So, you have a number, and programs like nursing homes and other places aim at the RDA because protein is expensive and it's cheaper to give people fat and starch. So, those proteins are doing a disservice. Chris is spot on.
Stu, I have a hypothetical question for you here.
Yeah.
And it comes back to, I guess, where we focus our attention and maybe placing some of this into context. It sounds like you're kind of loosely in agreement that the average person's protein intake.
Disappointing, isn't it? You brought us on, thought it was going to be a big, scrap. I think it's just different ways of looking at this same sort of issue. Yep. I might demur with Chris on certain things, but I don't, like, we're not miles apart. But if we use the RDA as the benchmark, then I tune out right away. I'll be honest, because I'm like, yeah, it's flawed. It's no basis.
Right. I haven't got the sound bites of conflict that I wanted to market this episode. So thank you.
Yeah.
Thanks, gentlemen.
Sorry.
But my question to you is around focusing our attention. So if we are thinking about the preservation of skeletal muscle as someone ages, so you said earlier that as people age, their protein intake is dropping off. Now, I'm also going to go out on a limb here and say that they're becoming more sedentary. And as I understand it, when it comes to the stimulus for preservation of muscle tissue, resistance training is a much greater stimulus than protein intake. So my question to you is the problem a lack of protein, or is it a lack of resistance training and stimulus? I learned in my undergraduate career, or undergraduate degree, I should say, that, when it comes to physiology, structure reflects function. So how much of this problem is caused by a lack of protein as people age versus a lack of exercise?
Yeah, great question. Clearly, you've been reading my Twitter feed. So yeah, I would never argue. Exercise or activity trumps, in my opinion, diet, particularly with respect to body composition and protein, like hands down. We don't have the money or resources to do the type of studies where we control diet strictly enough to look at the effect of protein on body composition. But from an observational standpoint, older people who consume more protein hang on to more muscle. They don't progress towards frailty. They fall less. And, much again to a number of people's chagrins, they don't live shorter lives. And so, as laudable goals for an aging person, I look to, some of the issues around, falls, which are, key watershed moments, and say, well, I don't know. It seems that there's an association with greater protein that may reflect greater physical activity. And if that's the case, then you're preaching to the converted. You wouldn't get me off this show without me saying that, exercise or activity is king and diet is queen. So, and if that means a hierarchy, then I guess I would be supporting that notion.
Mm-hmm. But are you saying as well, just to be clear, in elderly populations where protein intake has been assessed, are these populations consuming under that 1.2 gram per kilogram sort of target that you mentioned?
Some are. It depends. I mean, like the frailer and the more sedentary individuals, yeah, you can get them below the RDA. Some of them are close to the EAR.
Mm-hmm.
Interestingly enough, you put an older person in hospital for a knee replacement or a hip replacement and do trace studies on what they're fed in hospital or what the time they spend in hospital if they're there, they consume about 0.6 grams per kilo per day.
Mm-hmm.
So, there are situations where it's clear that people aren't meeting their protein needs. But I'm not saying on a population level, and this is where the nuance is sort of lost, is that there's rife protein deficiency.
Mm-hmm.
There's not. There's rife overeating of, as you mentioned, hyperpalatable foods for sure.
And to bring in another perspective here, right? So as you're aging, there's loneliness, depression, issues with dentition, bad gums, bad teeth. People just aren't eating enough, right? Is it really that they're not getting enough protein or they're not getting enough calories, they're not enjoying their food enough? So to help some of these folks, it's not just that we would have to get them more protein. It's that we would have to improve their mood, their social lives, look at their teeth, etc. So I think it gets even more complex. If we were, Stu, to have the money to do those kinds of intervention studies, and we don't, but it would be nice. So if anybody's listening that wants to give us those funds, we're open. There would be a number of angles to address, and protein would absolutely be one of them, but it would be one of several.
No, I absolutely agree. Yeah. I mean, aging is a complex problem and it's not solved by one thing or another. And then, that's the traditional grant getting reductionist type approach that's probably been oversubscribed to without trying to bring together groups of individuals to talk about complex issues like cardiovascular disease, cancer, aging, from multiple perspectives rather than siloed ways of looking at it. I wouldn't disagree.
Stu, you sort of just alluded to the fact that it sounds like you don't sort of buy the idea that a higher protein intake above the RDA is a concern from a longevity sort of perspective, an idea that's often put out there. I think that's what you were alluding to. But there does seem to be a bit of a divide, and this might be false equivalence, and it may be that more people are of the view that it's not a concern, but at least online there does seem to be a divide or a split among some of the prominent experts using social media and jumping on podcasts. Some like Walter Longo, for example, or David Sinclair, they certainly advocate for protein restriction, at least through midlife, and it seems that most of that is extrapolations from sort of animal research where branched chain amino acids or specific amino acids like methionine have been restricted in certain animals, models where they've been looking at lifespan. Would I be right that folks in that camp are mostly focused on lifespan, and whereas yourself or someone like Don Layman are sort of more thinking about health span and sort of mobility and how strong you are into older age. And if I am right, are you would prioritizing skeletal muscle, bone mineral density, etc., is that potentially coming at the cost of extra years of life, but improving your quality of life?
Yeah. Big question, lots of answers. First, the balance, and by the balance, I mean like 90+% of the evidence around protein restriction and longevity comes from small mammals. There is no protein restriction study in primates. There's an energy restriction study, and it depended where the primates came from, Madison, Wisconsin, or the NIH. And in one study, they lived longer, and the other one, they didn't. So that's energy restriction, which is a far more powerful lifespan extending intervention than protein restriction. So let me just say that I applaud the science that sits around, small rodent studies and models of deficiency of certain hormones like Laron dwarfs and growth hormone, for example, that are cited as examples for protein as the causative nutrient. And that's, I think, is a massive overgeneralization as giving rise to growth factors that restricts shortens lifespan and increases the prevalence of certain diseases. So I think it's a clever idea. The reality is, when you do a review of all of this sort of literature, is it's pretty gray. And we only have observational data from humans, obviously, but there is no consistent relationship between protein intake and longevity. None. And, let me just say that two colleagues of mine and I have had a paper in reviews. It's probably been rejected from several journals. And the number of times I've talked about it, people are beginning to suspect whether it's real or not. It's real, where we've looked at data and using the correct statistics and all of the mortality data that are out there, there's no relationship between protein intake and lifespan, or even between plant or animal protein and cardiovascular disease, cancer, or all-cause mortality. So, I begin to glaze over when people talk about protein restriction as a lifespan extending benefit in humans when you talk about inbred strains of small mammals that live in a cage, only consume that protein day in and day out, don't have access to a running wheel, never were exposed to a pathogen like a global pandemic, never spent extended periods being sedentary where they lose muscle mass. And as you say, maybe you live longer, but you don't live better. Chris chuckles, but it's the differences between those. Humans are an outbred species. So that, for starters, should give you some sort of, these mice are their brothers, cousins, brothers, right? They're inbred at, labs for years. And we're stunned when they don't actually act like, well, first, true wild mice that are real mice, not in a lab, or human beings. And so, forgive me for being a little underwhelmed by the level of evidence that is brought to that question. And I just I stand to be corrected but even my own work, with a couple of folks that hopefully you'll see sometime soon, suggests that it's just not a relationship that's there.
And I hope we get to move on to that animal versus plant, because again,
Yes.
protein is a nutrient. It's not a food. And when people go out they don't go to the grocery store
Yeah.
and buy protein.
Yes.
And buy protein. Yeah. Chris, I just got Chris's email just before I got on the show, and I quickly read it. And I think he brings up an important point around plant protein and amino acids and deficiencies and everything that I've been doing my best push back against around. Yeah, so I don't want to steal Chris's thunder because it's his thing, but this is a point on which he and I can solidly agree, and it's a narrative that it needs to change. So I'll just say that, and so Chris can.
Thank you.
Can we can launch from there.
Should we go from there? Or you want to frame that as a question, Simon?
I think that was a great segue. I guess we could start this off. So far, we've mostly focused on protein amount. So I think moving into source and therefore this idea of protein quality is probably a great place for us to continue on here. And perhaps even just thinking about what we've been talking about with regards to the amount of protein in someone's diet. If we are talking about this 1.2 gram per kilogram, which most people are already achieving, does the amount of protein that someone needs for optimal health change depending on the percentage of animal and plant proteins in their diet?
And a key area there, it does come back to this amount. So let me start out on this basis because I'm going to diverge from this if I get to rant on this. So plant protein quality is not as good as animal. It's not. It's not missing any amino acids. So if we could please start there. All plant foods have all 20 amino acids, including all 9 essential amino acids. And I made a fun heat map that I put in a paper in Nutrition Reviews in 2019. I can't tell you how many people have asked me for a copy of that heat map and to see if they could reproduce it, because it's pretty clear the distributions are almost identical, except beans have less methionine and cysteine, and grains have less lysine. They're not missing. They're just proportionally less. How important is that? It's actually pretty important. As soon as you run out of a specific amino acid, you just can't fake it as you're making an enzyme or some other protein structure and just substitute another one in. It has to be that exact amino acid. But let's say, okay, and so I'll try to be careful how I say this too. So let's say you needed 1.2 grams per kilogram per day, not 0.8. But you ate 1.6 grams per kilogram per day, and you got it from plants. Probably that extra 0.4 meant that you got enough lysine and you got enough methionine. Now, if you required 1.2 grams per kilogram per day and you got it all from plants and you got 1.2, it wouldn't be enough. You would have run out of your lysine or your methionine, cysteine first before you got to make all your proteins. So there is a point there about the quality of amino acids, but when we look at the data that we have, people are eating high enough quantities of protein all the time that they're getting enough of all the amino acids every single day. They're breaking down the extra amino acids they didn't need and they're converting it to carbs and fats. I can't tell you how many people are sort of bewildered when I do this one. I say, okay, how much fat can you store if you ate extra fat? And the answer is unlimited. Oh my God. And where? Oh, in your butt, in your belly, under your arms, in your jowls of your cheeks. Okay, how much carb could you store if you ate more carb than you needed for the day? Oh, very limited, like enough to run a marathon and not even quite that. You'd store it in your skeletal muscle and your liver, but it'd only be about 1 kilo. You can probably answer that better than I can, Stu. But I bring those two up because then I say, okay, now let's say you've eaten more protein than you need for the day, which just about every person I know does in terms of quantity. Where do you store it? Nowhere. There's no storage depot for protein. You have to break it all down, and carbs is the first priority. And if you didn't eat any carbs at the moment, you probably don't. You turn that protein into fat. And so for this whole issue of animal versus plant protein, it's relevant at some sort of low level. If you're not at that low level, it's irrelevant. You got all the amino acids you needed, and most people are able to do that, including vegans and vegetarians. And so just this idea that I can't tell you how my blood boils when I see another ad that says quinoa, the only plant that has all the essential amino acids. BS. They all have all the essential amino acids. Get out of here. So that's I have more ranting, but I'll pause for a minute there.
Can I just clarify one point, Christopher?
Please.
And I might have misheard you, but I just want to clarify this in case anyone was confused. When you were talking about, for example, legumes being the methionine being a sort of limiting amino acid, and You spoke about 1.2 grams or eating a bit more than 1.6 grams. I just want to clarify something. You're not saying at 1.2 grams per kilo, if someone gets all of that protein from plants, that they would fall short in methionine unless they were only eating legumes as their sole source of nutrition versus a diet that was providing a diverse range of plants, some that have a greater proportion of methionine?
Okay, so if you want to try to oversimplify it, let's say all your protein for the day came from beans, and you required 1.2 gram per kilogram per day, and you got 1.2, it wouldn't be enough. Okay, what if you complemented it with grains, which actually are a little high in methionine, even though they're low in lysine? It still wouldn't be enough. It wouldn't be quite enough. So plants together, even when you combine them, never make up the full complement of amino acids that animal foods have. It's not the perfect distribution, but you wouldn't be very short. It's not like you're short in a huge way. So you would have to eat 1.3 grams per kilogram per day or 1.4 if it was all plants. And the reason that I thought Stu and I were agreeing on email one day was it's kind of moot because most people eat 1.4, 1.5, and it just doesn't come up. But if you really did get them really close to that level of individual requirement, you would have to pay attention. But most people aren't there.
Okay, so let me ask you a question then, because within the kind of plant-based community, there are some doctors, and I'm not going to name names, that the advice is just don't worry about protein, just eat enough food. Do you think that message is okay, or do you think people that are eating plant-exclusive diets should be at least protein aware?
No, so I think that's correct. So thanks for bringing back to 30,000 feet. As long as you eat a variety of foods in your diet, I think you're going to get 16 to 18% protein, and you're going to be way above whatever your individual requirement is for total, and you're going to get all the amino acids you need. And let me make that even more practical, because as I've been giving a protein rant at some medical conferences that I go to, I started asking sometimes a group of 500 physicians, say, okay, how many of you have vegetarians and vegans in your practice that you look after? And almost everybody raises their hand that they've got some. And then I say, okay, can anybody raise their hand now who has ever treated any of them for a protein deficiency? And no one raises their hand. No one's ever raised their hand as often as I have asked this question. Now, to be honest, I'm not sure if they would recognize protein deficiency if they saw it, because it likely wouldn't be isolated. It would be in the context of someone who had other nutritional issues. But it's pretty funny when some of them in the front row assume, oh, there must be people in the back of the room that are raising their hand that have vegans that they've had problems with, and they turn around and see no one in the room has raised their hand. And somehow that's an aha moment. So one of my latest mantras is simply stop obsessing about protein.
Stu, anything to add there?
One of the things that fascinates me is you can go all over the world and every culture has figured out that a grain and a legume pair are the way to eat your protein. That suggests that there's a teleological lesson in pairing those proteins. And it must have been that, when food supply wasn't abundant, and remember, that's the last, 100 plus years of our existence as human beings, that when a stress came around, you died. And so if you were a bean eater and or if you were a rice eater, probably, which was in abundance, you just didn't make it. So it's only under stressful times where you're going to see something that's, and I mean famine, sickness or something like that, or your protein intake is very low. So, Chris makes a valid point. We've just got to stop saying that plants are deficient or insufficient in certain amino acids, particularly when people eat the type of diets that they do now. So, and again, I think you may have heard me say this on other podcasts, but this is something on which my opinion has changed. You asked me 25 years ago when I first started, exactly like Chris. I'm like, no, animal proteins are higher quality. They've got more essential amino acids. They're more digestible. And I'm beginning to think that that's less and less. In fact, for the most part, it's a non-issue. So I don't know about the obsession around protein. I don't think anybody's deficient. And I come back, is it requirement or is it optimization? Difficult questions, hard to answer. But, let's just stop, the rhetoric that plant proteins are, that it's just, or plants contain compounds that are trying to kill you. And I get it. That's a little extreme. But you can pick anything now on Twitter, and there's somebody out there that agrees with you, right?
For sure.
But it's a tired, worn out narrative. It's just and it's wrong.
Yeah, if plants are trying to kill us type rhetoric is interesting. I think if they are trying to kill us, they're not doing a great job. There's a little bit too much agreement happening here, guys. So let's just
sorry.
Let's change gears slightly. I'm interested in if we kind of open up the aperture a little bit here when we're considering protein quality, whether you think that definition should consider the environment. And I know this might seem a little left field, but it often comes up in the protein question. And there seems to be, at least from my read on it, some pretty clear benefits for the environment in terms of greenhouse gas emissions and land use in particular, if people ate a little less animal protein and more plant protein. So interested to hear both of your thoughts on that.
Can I go first? Is it my turn to go first?
Sure.
Go for it.
I had a lot of fun writing a paper on this in 2019. And what we modeled, Simon, was getting 25% less protein and shifting, not making people vegan or vegetarian, just shifting sort of the current distribution of total protein from the animal side to the plant side. And I got to work with an environmental researcher, and we just said, okay, what would happen to greenhouse gases? And actually, we were doing water use. I've actually been really impressed with Hannah Ritchie, who's on Twitter a lot, with Our World in Data. And she's actually modeled this kind of thing for land use and water use and eutrophication from nitrogen and phosphorus and biodiversity and greenhouse gases. There's really sort of 6 planetary boundaries that are out there. And I made a whole slide deck based on her interactive database. And across the board, animal food over plant food is more of a burden on the planet. Whether you do, and she has this option, you can do per kilogram of food, per gram of protein, or per calorie. And it really doesn't matter. It's just bluntly different. And so in the paper we wrote, we said, you don't have to go vegan or vegetarian, but if people, given how much protein they're eating, if they ate less protein and stopped being obsessed with it and shifted the type, you have a pretty dramatic impact on the environment. David Katz and I got to write a paper with a couple other fabulous folks and said diet quality has always been assessed in terms of digestibility and amino acid score. That's fine, except we propose those foods that you get it from come with other nutrients, higher or lower in saturated fat and fiber, which is usually better in plants, and a differential impact on the environment. So really, as you started to suggest, Simon, a true assessment of protein quality should probably take into account the other nutrients that come in those foods and the impact on the environment. And plants win, hands down.
Any comments on that, Stu?
Christopher knows a lot more about this than I do. I'm trying to learn. I'll admit to that. I don't dispute in any way some of the calculations that people have done. And I think the point is, as I signed off on my email or my Twitter thing the other day, it was, sort of unapologetically omnivorous, but there's lots of evidence to show that plant-based diets are healthier. I suppose my point would be, is it you can achieve optimal or whatever that is health on lots of different diets. And so I think that it's definitely a point worth considering. And, the broader perspective on where you get your nutrient, insert protein, carbohydrate, or fat, probably could stand to be expanded. And the environment is a consideration. And I don't know too many people that would disagree with that, but Chris is in the one country where the leader of his country said that it was a hoax. So, just point that out.
Yeah. Thanks a
Christopher,
lot.
Yeah.
Yep.
I know. It hurts Chris because he's on the West Coast and he's probably a Democrat and all this sort of stuff. So
Possibly.
Christopher, just to clarify something, you're talking there about substituting some calories from animal protein for plant protein. I think it was in one of your papers. If you look at the average American's diet today and you look at where their protein's coming from, correct me if I'm wrong, but 70 to sort of, I think it was 80 or 85% of that is currently animal protein.
Yes, that's what we found. So I think the highest I've seen is 85 and the lowest is somewhere around 70, 75. Yeah, and yes, absolutely.
Okay. I know that we're coming close to the end of this one and Stu's got to dart off. Let's finish with satiety. Often when protein is spoken about, the other thing that comes up is, well, it can assist with weight loss. It can help someone feel fuller on fewer calories. So I'm interested, is protein king when it comes to feeling sated, and therefore great for someone if they're wanting to lose weight?
I'm in, or I'll wait, Stu. Your
Can
turn.
I go first?
Yep, your turn.
I'm not a satiety expert, not by a long stretch. I'll say this: I've had the pleasure of speaking on lots of protein programs. I'm usually the exercise guy, and I've followed or listened to Rick Mattis, Marguerite Westerterp, Harvey Anderson, who I think are pretty good satiety people. From a macronutrient perspective, they'd agree that protein is the most satiating. Is it the only player in satiety? Absolutely not. I mean, I know enough to know that there are lots of other, satiety signals, stomach distension, so water, fiber, etc. I think I saw in Chris's email he wanted to talk about Barbara Rolls' sort of theory in this and volumetrics, and I'd be the first to say that personal experience, and Chris has got far more experience in weight loss trials than me. That there are multitudinous factors contributing to satiety.
Christopher, do you want to comment on that? And I think something just to add into that is, in addition to protein, how important is the sort of texture or the volume of the food or drink that protein's coming from? Just thinking about it myself, for example, a kind of pea protein shake in water for me, although it may provide 30 grams of protein, is not very sating.
Right. Yeah. So drinking is never very satiating. So it's much easier to drink your calories than to eat them. If you look at some of the literature on this, as Stu suggested, I feel like it's kind of all over the map. Protein is satiating, but fiber and the water retention you get there and the distension you get, that's satiating. And fat delays gastric emptying as it floats to the top of your stomach. So fat is satiating. And we never eat protein, fat, carbs alone. We eat them in combination. So I've always been really impressed, and I've cited this one paper often, and it is just one paper, but it was Barbara Rolls being very clever, and she made a casserole in 6 different ways. And the casserole looked the same to everyone, and as much as they could, it tasted the same. And she had, I'm going to guess this is students. I think this is how she does most of her studies. She had students come in on different weekends, and they would eat something, and then they'd monitor satiety with these visual analog scales, or how many calories they ate later in the day. And the casserole had 5, 10, 15, 20, 25, 30, 35% protein. It varied across an incredibly wide spectrum. And the participants ate the same number of calories at every level of protein. And they were asked to eat until they were sated. So I thought that was just fascinating. And just in terms of comparison, are those studies hard to do? She did another really clever one where she had 2 variables she was manipulating. And one was energy density and one was size that you could see visually. And she had multiple servings of these things on plates. And there were 2 energy densities. One was high and low. And for the low energy density, that basically just means it was the same dish, but it incorporated more water. And so that water diluted the number of calories, right? And then for the volume, they just served larger and smaller portions. And what they found was if they did 4 weekends in random order with students, again, I think they ate something like 500 calories less a day for almost either one alone. And when they put them both together, they ate 800 calories less for the day and said they were similarly sated. 800 calories a day. And so when I look at these things that say, yes, protein is satiating if you eat this way, it will make a difference. I'm going to say, kind of back to Stu, maybe it makes a difference sometimes, but I actually think other factors play a much larger role than the protein. And having said that, I will say if you take the standard sad American diet breakfast of breakfast cereal with refined grain, added sugar, multicolored marshmallows, orange juice beside that, plus a piece of white toast with some jelly on it, basically carb on carb on carb on carb on carb, and instead you had eggs and bacon and sausage, you would be more full on the eggs and bacon and sausage. But what was the comparison? It was a ridiculous comparison of all refined carbs and sugar.
Okay. Anything to add on that, Stu?
I nothing more to say. Like I said, I'm not a satiety guy. Couldn't say anything more.
Okay, great. Well, gents, thanks so much for doing this. I think it's fabulous that we're able to do this on podcasts, and both of you are offering such a great service to everyone. So I really appreciate your time and coming together to discuss this in a sort of long format. Just to leave people with something here, and there was a lot of things that you agreed on, and I'll get both of you to kind of comment on this. What are the take-home points for the average adult that is listening to this, is thinking about their nutrition? Is it going away and getting their calculator out and adding up the protein in all of their different meals, or should their attention be focused elsewhere on dietary pattern? Or what advice, takeaway advice, would you be giving that person who's tuning in and just leaving this thinking, okay, what next?
All yours, Stu.
So first, I mean, my takeaway is let's stop using the RDA as the benchmark and agree that whatever it is, good health, optimal health, dare I suggest, can be achieved with a variety of macronutrient intakes. My opinion is that the amount of protein that's suggested as being adequate, if that's the right way of saying it, isn't the RDA, it's more. And people should pay attention to that. Is the average person getting more than that? Maybe. But there are groups that aren't. I'm concerned about the elderly in particular. I'm not concerned about athletes, never have been, but let's just stop saying that the RDA is the benchmark. And so we're all, going to die an early death because there's no data for that. That protein's going to give us cancer, that protein's going to cause our kidneys to fail, that protein's going to make our bones weaker, because, all of those, minus the cancer, which is really only based on rodents anyway, have been debunked. But there are lots of ways to eat and eat well.
Okay, and I'll build on that. First of all, thanking Stu a lot for your discipline, which I fall short in. I know really nothing about those kinds of studies, so I really love reading your material. I'm going to close with stop obsessing about protein. Almost everybody gets enough. But I really like your perspective, Stu, of focusing on different populations. I would agree I don't focus on the elderly at all, and that is likely more of a concern than I've been able to address here. But I'm going to flip that. And I'm going to say I really wish the athlete community would listen to this, because I actually think some of that might be detrimental if they're getting too much protein. There's things they're not eating. I see athletes so obsessed with this that they're having 3 chicken breasts in our, elite dining center at Stanford University, and they're actually not getting maybe as many carbs as they need for long-term energy. And so if there is a concern for the elderly not getting enough, I'd be really interested in following your work to see if there's any detriment to some of the athletes being so obsessed that they're actually having a diminishing effect on their performance by being so obsessed.
Maybe the potential for a future study collaboration between the two of you on that.
We'll take
Sounds
funding,
great.
right? I'm up for the funding.
Yeah, like Christopher said, any GoFundMe campaigns, it's very welcome.
Okay.
Thanks,
All right,
Simon and
gents.
Stu.
I've enjoyed this. Great to have both of you back on the show, and
My pleasure.
Enjoy the rest of your day. Cheers.
Take care, both.
Yeah.
Bye-bye.
You too. Okay.
Thank you for joining me for this episode and your interest in science-based conversation. I hope you enjoyed it and found the information covered interesting and instructive. If you did and you'd like to show your support for the show, please subscribe to our YouTube channel where you can stay up to date with new episodes and watch them in video format. Yes, the full-length videos. Please also consider subscribing to the show on the Spotify and/or Apple Podcast app, wherever you enjoy listening to podcasts. You can also leave a review on Apple or Spotify. Again, a great way to support the show and make our content more discoverable for others to enjoy and learn from. If you have any comments about the episodes, suggestions for future episodes, including guests you'd like to see on the show, or questions that you'd like to have answered, please leave those in the comments section on YouTube. I myself and my team will take note of these comments when planning future episodes. Finally, the best way to support the show and receive discounts on products we love is by checking out our sponsors at theproof.com/friends. Enjoy your week, stay well, and I look forward to catching you in the next episode.